Okay, hey, myself Sourabh Jain. I am a solution architect at AWS. I support Georgia territory and mostly greenfield customers, and I've been with AWS for a little over 8 months. Before joining AWS, I've wear various hats, have been a software developer, then worked on consulting with Oracle applications, middleware layers, eventually transition into a role of application integration architect at Oracle, working on Oracle Cloud Infrastructure and cloud native application, and now with AWS. So today, I would be walking you through the modern data architecture on analytics, which we popularly call it as data lake. So what data lake is, what are the different components of it, and then we'll have a short demo after that. So I'll just show you, I have a reference architecture and I'm just gonna show you the different components, how a data lake is built and how you basically query the data and analyze the data. So if you look at the agenda for today, we're going to have the data trends, what our customers are facing problem and how we are solving it with this approach. Then we going to take a look at different technologies, which is powering this data lake. I'm going to do high level about Redshift and Athena. I'm not going to deep dive anything. And then we'll have a reference architecture, which is for demo. So I'm going to just walk you through that architecture and then we'll jump on the demo. So overall, this will be around 30 to 45 minutes of affair. And just a note, anyone has any question, just feel free to stop me in between. I'll be happy to answer it, or you can put it on chat. Uh, if I get time, I can take a look at it, answer it. So let's talk about the data trend. So at AWS, we like to work backwards from customers. So according to IDC survey, which was conducted in January 2020, it says that the data which is collected today every hour is more than the data which was collected 20 years before in a whole given year. So with that massive amount of data, it comes with a lot of challenges. So we divide those challenges basically into three different categories. The first, you have this data coming from different sources, be it your ERP, CRM, or your clickstream data, or your machine learning data, or you have your application which is throwing the data into your databases or anywhere else, right? So with this data, it could be in a structured format, it could be in an unstructured format. Now, what issue business is facing is it's very hard for them to do analytics on it because this data is sitting in silos and it's not in the, all the data is not in the right format, or you can say the data is not across the board in the same format. Another thing they are facing challenges now, if they want to start using machine learning or some more advanced analytics, it's very hard because data is sitting in silos. The second challenge which we are seeing is nowadays users want the data real time. In some cases, they want data like to be pretty quick from a performance perspective, query performance perspective, or if they are looking at dashboard, they want to make sure it appears pretty quick. It should not take much time. Also, from an ingestion perspective, the data should be there when they need it. Like if I'm coming in the morning and I need that data to do my work, that data should be there. So what's happening is if we miss SLAs, then it creates a bad user experience or customer experiences. From an IT manager perspective, what we are seeing is IT managers nowadays looking at like a minimal management of infrastructure, or in some cases, they don't want to even manage the infrastructure. They want to manage service kind of offerings. Also, from a scalability perspective, they want their platform to scale as much as it can, like depending upon their workload as the business grows. And apart from these two factor, you have third, which is your cost and security. So you need all these issues to be resolved. At the same time, you need a solution which is cost effective, highly secure, and also which basically compliant to all your compliance needs. So if it's not complying to your compliance need, that the solution will not be of any use to you, right? So we heard our customers and we come up with an approach. We call it as a data lake approach or a data warehouse approach. So what this approach is, you have a single source of truth where you have your data sitting. It could be a data lake. Also, you have an easy access to the data across the different sources of data. It could be a relational, non-relational. We'll be talking more about in the next slide what that data, like what are the different sources of data you could basically combine together. So that's the first thing, right? Single source of truth, easy access to the data. Second, should scale as much as you want. This architecture scale as much as you want, depending upon your need. And these are all managed services. So basically, you don't even manage underlying infrastructure. You only focus on your core logic, core data analytics stuff, and core business stuff. The third, but not the least, is the cost. So you only pay for what you use. And from a security perspective, it's highly secure. So you're going to get the tools which are some of the highly sensitive security customers are using. Also, it's compliant from the compliance need. So in overall, if I take a gist of this model, it's first single source of truth, easy access to the different sources of the data from one place. Second, scalable and managed service. So you don't worry about basically scalability or managing your infrastructure. Third, you only pay for what you use, and a highly secure model. So that's the gist about this whole architecture. Now let's take a look into what really lights this engine. What are the technologies or what are the services behind this, which we are, uh, which you can leverage basically to light this whole thing, right? So your journey starts with your data lake, which we call it as S3. So you can store as much data you want. As you know, S3 is as scalable. You can store as much data you want. You can store data in any format, be it CSV, JSON, Parquet, or even there are some 2 or 3 new formats which you can store the data in, right? Now you have your data in S3. Now you may have some purpose-built databases, or you may have some other sources of databases, right? So you can even connect those data sources such as DynamoDB, which is your non-relational database, or you have relational database. So you can even basically connect those data sources into it. Now, if you have your big data stuff, like you are doing some big data capabilities, you can use Amazon EMR, which is our big data platform using Hadoop or Spark or Hive. So you can basically utilize that as well here. You have Elasticsearch if you are using some search engine or open search capability, you can even connect that here. Now, if you are using a data warehouse perspective, like if you are having a data warehouse, you can use our Redshift offering, which is our data warehouse product, which can easily talk to your data lake, or which can even fetch the information from data lake for analytics perspective. So this basically talks about the storage. Now you may be wondering, I have my data stored. Now, if I want to do a transformation on it, or if I want to create an ETL-based pipeline, how I do it? So we have a tool called AWS Glue, which basically helps you out in transforming the data, extracting the data. It has a lot of different functions, but in and overall, this tool basically helps you out in transformation and creating your complete ETL pipeline. We will talk about Glue in our demo. So I'm going to show you at a high level what Glue is, what capability it has. Also from an integration perspective, like from moving the data to one place to another, or ingesting the data from different sources, we have different serverless-based technologies, which is Kinesis, MKS, or SQS, which you can use basically to pull the data into the different sources or to push the data across the different sources depending upon your need. So that's about you have your storage of the data, you have your ETL pipeline with Glue and different serverless technologies. Now you may want to visualize that data, right? You may want to do analytics on that data. So the way we have the tools which can help you out in analytics is first is Athena. So you can directly basically go and use Athena to query the S3 data lake where you have stored the data. So you can go write your SQL queries, and basically you can do analytics on it, or you can even connect that to different visualization tool, be it Tableau or Power BI or QuickSight in our scenario. Now, if you have some complex business scenarios or complex queries from a data warehouse perspective, then you can use Redshift, which is our data warehouse engine, which works on MPP or columnar storage based format, which is multiple parallel processing. So if you have some dashboards which are requiring a very complex data sources, or which require complex queries, you can use Redshift there. Now, you have visualized the data, you have done analytics on the data, the next stage, you may want to do machine learning on it, right? So we have SageMaker, which easily connects to all of these different data sources, which can fetch the data from different sources. And basically, you can run your machine learning models. You can create your own models, or you can even use our auto-glue functionality, which basically provides the models for you to run on top of this platform. So that's how you do it, right? You store the data, you basically have your extraction, transformation, and load using Glue and different serverless technologies, and then you visualize or analyze the data using different tools like Athena or Redshift, or if you want to do machine learning, then you can use SageMaker here. Now, once you have your storage and everything in built, now you may be worrying about security. So we have something called lake formation, which can help you out in basically making sure your data is secure at the granular level, which could be at the row level. So you can start building from a row level to the top-notch level, or from a security perspective, we call it as defense in depth. So you can basically start securing your one layer and keep on building on top of that from a security perspective. Apart from that, we even have tools which can help you out from the threat detection. So We have Macy, which can basically look at if any of your data from a compliance perspective, like PCI compliant or PCI compliant data, it can detect it. You can even create alerts using Security Hub or config if in any case something is something suspicious is happening in your sources. So that's brief about the security. Now, the whole from a cost perspective, you only pay for what you use, and each of the services has a different kind of cost structure. But overall, this is a model which is a cost-effective and highly performance-based model. Now, I'll stop here and see if anyone has any questions. I mean, I've spoken a lot of things from this model. If anyone has any questions from the model perspective or from a technology perspective, I'll be happy to answer it or take it.
Sourabh?
Yeah, sure.
This is James Hallgren. You've got your diagram here. The Redshift and the Athena.
Yeah.
They're like parallel, right? I mean, so you could stick Athena in the center of this as well, right? I mean, not that your diagram is gospel or something, but I mean, is that correct that you could potentially connect all of these different applications to a Redshift just as easily as an Athena backend?
That's a very great question. I was expecting that question. So let me give you this perspective. So you can use Athena to basically query all of these data sources. But in case you require a very high performance based query, or from a business perspective, you're looking for a very SLA based kind of perspective, then you always use Redshift, because Athena will not be able to meet those needs. Like if the queries are complex, if they are taking longer time to run, then Athena will not be able to meet those needs. Redshift is the right tool for it. But to answer your question, you can replace these two tools interchangeably. But those both has different functionalities in terms of their underlying infrastructure or underlying structure. Redshift is like a pure data warehouse system, whereas Athena is not a data warehouse. Hope that answers your question.
Thanks.
Okay.
If you have a chance later, as you're doing a demo, it'd be interesting to see some of the performance differences. Just to, whatever you can do to illustrate that would be helpful. Thanks.
Yeah, sure. I'm going to show you in Redshift the performance thing. Yeah.
Cool.
Okay. Anything else?
Yeah, there are also certain queries that Athena can't run, correct?
Yeah, in terms of like if you are, so let me give you a scenario. If you have some complex procedures or complex those kinds of things, Athena wouldn't be able to run those. That answers your question?
Yeah, thank you.
Okay. And I can send you like what Athena can do and what Redshift can do, a difference after our call, but that's a very great question. And I come across that question very often, like difference between Athena and Redshift.
Yeah, I run Athena queries a lot, and sometimes I'll get Athena, the query's not supported by Athena.
Yeah, sometimes it happens. Yeah. If it's a very complex join, then the Athena will not support it. Okay, so moving on to the next, I'm not going to deep dive into Redshift or Athena a lot, but I just want to give a brief introduction about both of the tools, what it is. So Redshift is our fully managed, scalable cloud data warehouse that accelerates your time to insight with fast, easy, and secure analytics at scale. Redshift is fully managed. Serverless, it comes in two ways. It comes in serverless, which we recently launched, or it also comes in managed offering where you can manage your underlying cluster. Now, just to put three important benefits of Redshift. First, you can analyze all your data at one place. So you can have your data sitting in S3 data lake. You can have your data sitting in purpose-built database. So you can basically create a query which can query across your data sources using Redshift. Second is performance. So Redshift performs 3x better than any other cloud data warehouse in the market because of its underlying technologies, such as MPP, which is multiple parallel processing, or the caching capability of Redshift, which basically almost perform 10x better performance than the regular query. So what Redshift does is it caches the result into its caching, and it automatically validates that result as the underlying data changes. So you don't have to basically write a new query every time or query underlying infrastructure every time to get the data out of it. And another thing from a performance perspective, Redshift automatically basically tunes your query when you write it with its underlying machine learning algorithm. And even you can tune your query by yourself with different tools which Redshift provides. And last but not the least, the cost. So with Redshift, you can start with 25 cents per hour and then keep on building on top of it as you increase your data or scale from a scalability perspective. Also, you can also utilize the reserve instances, which could be 75% cheaper than the on-demand instances. So that's brief about Redshift. Uh, there's another slide. If anyone is interested, I can definitely send, which is more of what are the underlying features of Redshift. Like there's one important feature which I like a lot with Redshift is you can easily connect Redshift with some of the public data sources like Facebook. Like I won't call Facebook, like Google has some public data sources. You can easily connect Redshift with it. And I'm working with one of the customers in a restaurant chain, which is basically fetching the data from this public data sources to basically do analytics on it with their regular transactional data. Also, you can easily connect to Salesforce. Another feature I liked of Redshift is you can basically have a SaaS-based model on top of Redshift. So you can basically create the data sources which you want to share with your customers or your users, and you can even charge on it. It has that inbuilt capability to basically utilize the pricing functionality from a sharing perspective. So that's brief about Redshift. Let's talk a little bit about Athena. So Athena is a interactive query-based mechanism which you can use on top of Amazon S3 to basically go and query that. So it's a simple SQL-based query editor where you can go and query your S3 data. You can even connect your purpose-built database using different connectors, but it doesn't come inbuilt or inbuilt into Athena. You have to basically connect the connectors in order to do the connection to your DynamoDB or relational databases. And we have guide for it, so it's not like you have to custom build everything. We have guide. You can use those guides basically to build your custom connectors on top of Athena. The important features of Athena is it's serverless, so you basically don't manage underlying infrastructure. You just go and start querying it. So if you have your data sitting in S3, it could be petabytes of data, you can just go and query that data. Second important is it's an open SQL, so it supports different format like Parquet, CSV, JSON, Avro, and other standard formats. So you can just go and query your data directly there. And the last but not the least, I would say, is the cost effectiveness. So with Athena, you basically only pay for what you use. So you only pay for the queries. So if I want to give you a number, you are charged just $5 per terabyte scanned by your queries. So you're not paying if you're not querying the data. So it's a pay as you go model in Athena. Any questions on Redshift and Athena? If I can answer. Okay, I will think no questions. So this is a reference architecture, what we're gonna look today in our demo. Three things I want to accomplish with this architecture. First, I want to show you how we can connect different sources of data and query them together using Redshift. First thing. Second thing, I want to show you the performance, which we just talked, like how fast the Redshift performs from a query perspective. So we're going to almost scan 3 billion rows of data into it and see the performance there. And the third but not the least, I'm going to show you the analytics perspective of it. Like I'll connect it to QuickSight and just want to show you how easy it's to connect to QuickSight, create the dashboarding. I'm not going to show you a lot of creation of dashboard, but I'll just show you one data set is how you can fetch it and create different kinds of dashboard. Talking about the data sources here, I'm going to have three different data sources. The first data source is my relational database, which I have spin up a cluster in my environment, which is a PostgreSQL. So we will use that to connect into, like, we'll use Redshift to connect directly into that operational database. Second is your third-party data. Now, this is very interesting, and you may utilize if you guys start building it. So this data could be bring it in different ways. One way could be I can directly go and push that data into Redshift using different APIs or SQL-based copy commands, right? So I can directly take that data and push it into Redshift. Or the another way here could be I have my data which is sitting in my S3 bucket, and I can go and copy that data into Redshift. So that, and there could be more multiple ways to do it, but I just showed you like two ways. Is one is you go directly call APIs of Redshift, push the data in. Another way is take the data from S3 and do a copy command into Redshift cluster to copy that data. So I'm going to also show you how you copy that. And the third, but not the least, is your data, which is sitting in your data lake, which is your S3 bucket. So this data, assume like, take a scenario, you have a clickstream data of your website. So you have data from 10 years, but you don't want to store all the 10-year data into Redshift. You only want to store the data of 1 year into Redshift, and rest of the data you just want to store into S3. But still you may need that data to query it, to run your analytics or to run your machine learning or something on it, right? So what Redshift provides is you can keep your data stored into your S3 data lake, and you can directly query from Redshift, which is service called Redshift Spectrum. So you basically save the cost of storage from a Redshift perspective. At the same time, you are able to query that data whenever you need it. So if you're not worried a lot about performance, or you're okay with like, I'm rarely using this data, then you can basically use this mechanism here. So that's a brief about architecture. Any questions on architecture before I start the demo? Anyone? Okay. So let me jump onto the demo now. So this is AWS Management Console. Let's first look at different data sources. So I'm going to take a look at my first source, which is my RDS here. So I'm going to go to RDS. And show you the DB clusters here. So this is my database, which I'm already running. I'm going to just query this data here. Postgres, connect to database. So I have customer data sitting here. If I query this data here, you can see I should have 5 rows here. So that's my first data source, which is just sitting into my database. I'm going to directly query this data using Redshift cluster, but I just want to show you my sources. That's my first source. My second source is, let me pull that up. The screen is challenging. So this is the data which is sitting into an S3 bucket. So this is a data source of third party, which I was talking about, right? So what I'm going to do with this data is I'm run a copy command into my Redshift and copy this data directly into my Redshift cluster. So assume like you have your third parties which are pushing the data into S3. So this is one thing, one way to do it is push the data into S3 and copy directly into Redshift. So that's my second source of data. And my third source is my S3 bucket. So let me pull that. So here you can see this is my data lake, which I created. And it consists of my clickstream data from the user. So you can see different customers has a clickstream data stored for each of the month. And this is almost like 3 billion rows of data, which we're going to query into Redshift. So now I have shown you all my different storage mechanism, right? My relational database, my S3 bucket, my third-party data. Now let's take a look at AWS Glue, which basically go and transform this data. So let's go here. So this is AWS Glue, which helps you out in ETL process. So you can create your ETL complete pipeline here, one thing, or you can create your transformational jobs like if you have a job, if you have some use case where you are pulling the data from an S3 bucket, then you want to do some transformation on that data, you can do that here. So it's pretty easy. You can basically, let me show you one job. So you can basically come and say, hey, this is my target, my S3 is my target, and my source and my target is, let's say, MySQL, right? I can just go and create a job, and it creates this kind of visual. So you can you can even write scripting if you want to. So as of now, it's not going to create scripting, but you can choose like your uh, source, and you can apply mapping from a transformation perspective. So you have a lot of transformation function, like you want to filter it, union it, aggregate it, good stuff, right? And then also you can write your own set of programming here. So it works on Python-based programming, and it supports a Spark-based framework. So you can basically write the whole coding logic here from a transformational perspective, or if you are using any libraries, external libraries, you can bring that into the code here. I don't think I can show you the script part of it, as I don't have any job created here. But that's a brief about Glue job. Now, the thing which we are interested from a demo perspective today is, let me go Glue again here, dashboarding, is the data catalog. So what is a data catalog? So let's take a scenario here. I have my data which is stored in the S3 bucket, right? Now I want to catalog that data. What do I mean by catalog here is, catalog is I want to see what are the different columns in that data. What are the, like, simply say, okay, this data consists of this many columns. So in our case, we have our user visit table, right? So you can basically crawl into the S3 bucket, and it automatically brings the schema for you. So this schema, which you can use to basically go and query it. So what it does is it makes sure you don't have any file which is not in a right format, and it also makes sure you have a fixed set of schema here. So you can create all kinds of data catalog in this AWS Glue, and that's what we did for one of our data source, which is our data lake, which we have cataloged it. So you can see it has all different columns for the user visits of a clickstream data. And you can also see the record count. It has almost 3 billions of rows here. So any question on Glue, anything you want me to touch off quickly? Anyone? YC2 chat, no. Okay, now let's jump on to Redshift. So if we look at our architecture here, let me bring my architecture so that we can be clear what we are looking at. Hold on for a minute. So if we look at our architecture, what we have seen is we have seen all these three different sources as of now. Now what we're gonna see is we're gonna see the Redshift piece of it. So let me pull the Redshift here. Amazon Redshift. As I told you, like Amazon Redshift works on the cluster. So you have your leader node and you have your child nodes. So basically it's a clustering based framework. So when you run your query, it automatically breaks that into using different partition key to run those queries in parallel in different clusters. So this is the cluster, and it will show you how many number of nodes I have. So currently I have 2. You can increase it depending upon your need. So this nodes basically helps you out in running your query in parallel in different nodes. If you have a bulk of, like if you have a huge amount of data querying need, you can basically increase the number of nodes here. So that's the number of nodes here. And with Redshift, you can in this, you can look at different performance perspective, like how my queries are performing, what is my CPU utilization, database connection, duration, all of those things. It can easily connect with CloudWatch as well, which can help you out in monitoring or creating alarms in case any of your queries taking longer time, or it's failing, right? You can create an alarm here, and that could basically trigger an alarm, and you can perform the next step of the process there. It can even like you can monitor your queries using query monitoring tool here, like how much time it's taking, what is the load time, everything. You can even look at the database performance, the workload concurrency, in case you have. Yeah, I forget to mention one of another important feature of Redshift is the workload management. So in Redshift, you can define the priorities of different workloads. So if you have a workload which is of higher priority and it needs a lot of cluster or it needs more query performance, then you can define that priority and Redshift will keep that priority in order. Like, okay, hey, this workload requires to use more resources, so let me run this. The other workload which you think, hey, that doesn't have a lot of performance need, you can define the priority and that would use lesser number of resource. In terms, it will help you in doing two things, making sure the workloads which have priority are run faster, and also from a cost perspective for the workloads which doesn't require a lot of resources, those doesn't run here. So that's brief about the Redshift. Now let's do a query here. So I can go here and do a query in query editor. So let's first take a look at this database, which is our operational database. So what I have done here is, if you can take a look at here, I created a schema here, which is I'm directly querying from a Postgres database. And I've like given a database URL link here. And that table is this one. If we go here, it's connecting, just give it a minute. Okay, it's connected. If you go here and look at Postgres and tables, it should have a customer table here. So I can basically go and query this. So you can see when we ran our cluster, we saw 5 customers. So here is also 5 customers. You can directly query it from your Postgres database. So that was our first data source. Now our second data source is our third party, right? So with this, what I'm gonna do is I'm gonna run a copy command, which is basically copying my customer data into my customer table here. So I'm gonna just go and run it. And it's pretty quick. It copies millions of rows in seconds. As I even just have 2 nodes, it copies pretty quickly. So you can see it copied the data, and this is my return row 0. Oh, interesting. And then if I count this one, it has this much rows here, 21000. So that's the count. So that's this source, right? Now let's go and look at the third source, which is my data lake. So which is your clickstream data. Just look at the table here. I'll open this one. So that's my clickstream data here. I'm not going to query this because it almost has a billions of rows. It may take time, but I have a query already defined here to show you like how fast it performs. Like, so I'm querying my clickstream data with the combination of my customer table data. So I'm combining both of them and querying it together. So if you look at it, it's going to be pretty quick here. And we'll also look at the query time. Okay, it did it in 8712 milliseconds. Let's look at the query time, how much time it took and how much. So you can see it almost scanned close to 570 millions of rows and this much petabytes of data, and it just took 9 milliseconds or 8.72 seconds to basically query this data whole completely. Any questions on this? Anything else you want to see here? Are we going like, are you guys getting where we are going, or am I going off track?
No, I think this is a great start. Thank you. The group tends to be a little quiet and just take it in a lot of times, but yeah, everybody be
Yeah, please be open. You can ask me any questions, anything. It's an informal discussion.
Yeah, love to hear questions. Like to hear ideas of where you could see this applied in projects that you're working on, or you know,
I'm gonna
any experiences you've had, you know, doing similar? It's always great to get a conversation going in these.
I'm gonna jump straight into my question. I have to leave here in a minute, but the you know, one of the reasons I mentioned this earlier, we're trying to set something up. We're looking at some hires. We're trying to create something that's based on some data that's stored in S3, but is probably not optimal in terms of entry into a Redshift database. You know, it's not built as a table. It's a clunky NetCDF data set. So that's what I'm thinking about is what are the translation costs to, you know, if you've got a non-optimized native table that you're trying to pull into Redshift or potentially Athena, what are some of your
So
performance?
that's what I was showing you. Like you can always use Glue basically to do all of your transformation. And
Yeah.
I can't speak on the cost, but Glue is a very minimal cost. It's not a very too costly tool, depending upon how much like it also depends upon the worker nodes underneath which are running your job to transform that. So depending upon your how many rows of data it scans, that would be your transformational cost. But Glue comes with a lot of transformational capabilities. So it basically you can write your whole job into a Python-based coding tool which utilizes Spark. Or if you want to use any other libraries, you can always bring that library into it.
Cool. Yeah, that's where
Yeah.
our pain point's going to be.
No, I think if we can speak on it later. If you want to speak, I can go over it and we can even work with you on that. That's fine.
Cool. Yeah, I'll send you a message in the meetup.
Yep, that works. Yeah.
UI.
Okay. Thanks for that question. I think till now what we have looked at is we have looked at this resources, like how we connect it. We also looked at Redshift. Now at last, I'm just gonna show you how you connect this all tools into a visualization tool called QuickSight. So here I'm just gonna query QuickSight, bring QuickSight up really quick. Quick update, I'm very weak in dashboarding, so I'm not gonna create much of dashboards, but still I'm gonna show you how you can pull the data sets and how easy it's into, like this all data sets can be pretty quickly pulled up into QuickSight and do visualization on it. So I'll just click on data set here. So this is QuickSight, which is our visualization tool. It helps you to create graphs, dashboards, do analysis on your data. You embed your analytics into your website or into your application. Also, it has a very quick, very cool feature, which we call QuickSight Q, where you can just type your questions and different machine learning algorithm, depending upon your data, on back of it can bring the answers for it. So simple scenario here, if you have your sales data sitting and you want to know the sales in California. So with QuickSight Q, you can just type a question saying, okay, what is my sales number in California? It will automatically bring for you. So that's a pretty cool feature of QuickSight. That's one of it. But here I'm going to just show you how you can pull the data set. So you just create a data set here. You have different sources which you can pull the data in. These are all AWS sources. Some of them are GitHub, Twitter, Jira. You can even query, like I'm going to go and query Athena. So I can type here, not Athena. Let me query Redshift here. That will be quick. So I'm going to do a manual connect. I'm going to do a Redshift database. This is my cluster. My port is, let me bring up that information. My port is 5439. My database name is dev. Username is AWS user. And my password is AWS user 123. I can validate the connection. Okay. So you can see this database is coming here. So if you look at here, I have all of these data sources here. I can pull them all into my QuickSight and create the dashboard. So I just take the public data. I should have my customer table. I can just select it. And this Spice is the underlying infrastructure. So basically you're bringing the data into the QuickSight platform. If you don't want to bring that data into QuickSight platform, you just want to query it. You can just click on direct query data and click on visualize. And then you can create multiple kinds of dashboard. Like, let me see if I can create this one. Like, give me the, I think, region. See if this pulls up. Yeah, you can see my different regions across the board, like how many, what's my revenue across different regions here. So you can basically create different visualization effects from these tools. Any questions on QuickSight? Anything you want to see in particular on QuickSight? QuickSight can do a lot of stuff. I just showed you a simple pulling of data from a Redshift just to show you, like, you can basically pull the data from all sources from one place, which solves our purpose of single source of truth of data. So if your data is not sitting in silos now, you can query across the board from different sources and create your dashboarding and do analytics on it. Okay, I think that's all from a demo perspective. So we have seen the different sources of data. We have seen Redshift. We have also seen the analytics tools called QuickSight. So it solves my 3 goals, which is show you how to query the data from one place, shown you the query performance. It almost queried 500 million rows of data in milliseconds. I won't say millisecond, in seconds. And then the third is we did the visualization using QuickSight. So those were my 3 goals from a demo perspective. And I think I showed you. Any questions, anything? I think we are almost at the end now.
Anybody got anything to add? Any thoughts on what you've shown? This was a really terrific encompassing example. Saurabh, thank you. I think certainly also this will be available through the Birmingham AWS YouTube channel. We'll put it there for a lot of the people who are probably out with their kids on spring break right now. Like this is just content like this is great to see a full ecosystem of how to stand something up like this and begin considering how to apply it to your own projects and your businesses from really a complete POC like this. So I really appreciate you pulling this together for us. Any closing thoughts from anybody else? Ideas of how to use this? Any remaining questions for Sourabh or experiences with similar projects that you'd like to relay?
I've got one comment, Jeremy. So one of the things that's important to remember here is that your data is sitting in S3 in a lot of cases, in most cases, frankly, with regard to this. And one of the key elements that people, for whatever reason, seem to forget is that when you turn versioning on in S3, if you do some transformations and you end up with a different data set, you still always have your old data. You can just roll back to the fed if you happen to be overriding or you happen to be modifying in place. It's possible to get back to where you were if you do some things like, I don't know, I'm just going to say like I might have done once or twice where I just destroyed an entire data set. You do have a path backwards always, and that makes this process and the cycle of things very, very valuable in that you're not you can do all this most importantly safely.
Yeah, I think that's a great point raised. So that's the capability of, like, those are the advantages of it, right? You can roll back if something goes wrong. Yeah, that's a good point raised. Okay, I think that's all from my